Now the relationship between object should be, you should identify the boundaries of the object. This is the boundary of this object. Sorry, this is the boundary of this object. This is the boundary of this object. They are separated. Okay. If you define object like this, now this is not. They should be independent, separated. Okay. Now, but that means that what? They have a clear boundary. This is my boundary. This is my stuff inside. And this other object say, this is my boundary. Okay, nobody can cross it. Okay, but at the same time, they have operation inside. They have some operation inside each one. Okay, these operation make them what? Collaborate with each other. I can call the function inside this object, and this object can also call some function from this object. That means they are collaborating. I say the collaboration either by calling a function or by sending a message. This is considered as a collaboration. Okay. Now the relationship between object as drawing as the relationship between a class. Okay, by using links and aggregation. Links basically is just a connection between two objects. If you have an object here, this is link between them. So just a line between these two objects. Okay. Now a link, okay, could be used for the object to do some rules. Okay, to do rules. Okay, it could be the object can be a controller or a server or a proxy. Okay, a controller, okay, can operate on other objects. If you are a controller, that means you have control. You have control over other object. Okay, it could be operate on other object operating on other objects. So you can have control on some other objects. A server does not operate on the objects, okay, but it's only operate on other objects. Okay, its server is more like a server. Okay, the proxy can be both. Okay, now see the difference. Controller can operate. Okay, can operate on other object, but it cannot be operated by other objects. So he's what? The controller. He's the boss. He can control everyone in the company, and no one can control him. Okay, no one asks him what time you come, what time you leave, but he asks everyone, well, you should come on time, and so on. So he is the controller. Server, it does not operate on other objects. It's only operated by other objects. So server mean what? Everyone is controlling this object, and he has no control in any object. Okay. Proxy is both. Could be a controller, and could be a server sometime. Can be controlled by others, and it could control other as well. Okay. Now, when the object send the message to another using the link, now we say what? These objects are what? Synchronized. We say they are synchronized. Okay. Okay. They are synchronized. This is very important. You need to know that. Whenever an object passes a message to another object across the line, they are what? Said to be what? Synchronized. Yeah, they are socialized with each other. Similar to when you say, okay, I can talk to this person. That means you socialize yourself with him. You can talk to him. But sometimes you are not socialized with other people. That means you are not synchronized with these people. You don't like them or something more like this. So the same thing in real life is implemented in programming. Now the aggregation is basically means part of. Okay, it means part of. It's a relationship. It means you are part of me, something like that. So this is this is another object is part of this object. It is part of the object. It means cannot be outside me. Okay, so for example, I will give you an example. For example, yeah, this is a class A, this is a class B. They have a aggregation relationship, and the aggregation implemented using this. Okay, that means class A aggregate class B. That means class B is part of class A. Okay, the part could be what? Could be independent. For example, you have a computer is an object. Okay, you create another object called CPU. You create another object called keyboard. Okay, memory. These are all objects. Okay, and the computer is an object. What's the relationship between computer and the others? It is part of the computer. It is part of the computer. Okay, something like that. I hope you understand this from the similar to the car. The car has part, engine, wheel, tire, and so on. These are part of the object. Okay, so the whole object aggregates small objects. Okay, now it could be independent. It could be no way that we can split them. Okay, for example, computer and CPU. Do you call the computer if there is no CPU? No, because now this is called what? Strong aggregation. That means what? It cannot be separated from this part. It could be separated, for example, like a car. The driver, the driver drive the car. So the driver is part of the car. Okay, or a taxi, for example. But if the driver leave the taxi is still the same taxi. Okay, so they can be independent with each other. I hope you understand what's the meaning of aggregation. I'll give you more example. This is the computer, CPU, hard disk, monitor, and keyboard. They all part of the computer. Okay, so we saw computer aggregate all these things. Okay, now composition is aggregation, but a strong aggregation. I already explained that. Now this is the normal aggregation. A team contains players, but the team still team. Even if the player leave, the team still team. Okay, but the book contains. Okay, if there's no chapters, there's no book. So same as the computer. If there is no CPU, no computer. If there's no engine in the car, no computer. This is called strong aggregation. We call it another name. We call it what? Composition. When you feel that the relationship is part of, and this part cannot be separated. When you destroy the main part, the small part will be destroyed. That means a strong relationship, strong aggregation, which we call what? Position. We call it what? Composition. I have some examples already in the slide. You can see that a car and its part. The car has engine, wheel, and so on. Okay. Now some of the car part are not really, functions. Okay. So for example, like seat or anything like that. But when you say aggregation, that means we can split the seat and change it to. But when you remove the engine, the car will not be a car. The operation or the behavior of the car will not be performed. Okay, so that means there is a strong relationship between them. Now the aggregation, the normal aggregation means include the object. Okay, without being like attached strongly to the object. Okay, such as the team can exist without a player. Okay, something, a house has a parent. Okay, and the room a child. Okay, so you are family. Okay, you are family, and the family contains son, daughters. If some of them separated from the family, got married, Okay, that will not destroy the family. The family is still family. So this is aggregation. Okay, but if the parent, the father and the mother, then there is no family. The family is destroyed. They become separate. So this is called composition. Okay. Okay, now we talk about, in order to explain the relationship in much more better way so you can understand it, we will talk about the class. We'll talk about what's the class and what's the object, because they are the core of the object-oriented. Okay, the class is basically represent a blueprint for the object. It is just a template for the object. Okay, so the structure and behavior object are defined into a class, such as student. Student is a class. Well, which object including in this class? All of you. Abir, Al-Muayyad, Amani, Aya, Bashair, all of you are included in this object because they have the same behavior and the same properties. So we put them into what? Into a class. Okay, so the class basically is a collection of objects have the same what? Character or property and the same. Okay, now when you create an object, okay, as create an object, okay, we call this one what? Instantiation. Instantiation. Okay, we use in Java the word new. If you do any programming, we say, for example, x, or to say, for example, string. Okay, for example, x equal new string. So when you say new, you create an instance from the object. So instantiation is happen when you create an object from the class. Now, instance and object are interchangeable. You can say this is an instance of the class or this is an object of the class, but not everything, okay, is object. It could be an attribute. Okay. When I ask you, for example, to give me an example of the object, some of you say Canon camera. Okay. Now this is what? This is just an attribute of the object. It's not an object. So be careful. Okay, when you choose which one is to be object and which one should be an attribute. Okay. Operation, as we said, represent the function inside the object. Okay. We can call them behavior, we call them method, we call them function, and so on. This is the class. Remember the definition of the class, and the class represent a collection of the object which are having the same attributes, the same behavior. Or there's some differences. We talk about some differences between them. Now this is an example of an object and a class. Okay, the class is an abstraction, a way of classifying similar objects. We already mentioned that. For example, this is a girl. A girl is a class. You see, all these are girls. Okay, but they are girl. Okay, same thing when you say they're a class called boy. It collects all boy, old, new, young, different weight, different color, different style, different tall, and so on. Okay, so remember this picture, and I should put your picture actually to so make you remember the meaning of the object and the class. So when you create an instance from the class, you create a new object. This is a new instance. This is a new instance. For example, this is a new instance. This is, for example, Rahma. Okay, this is, for example, this is Aya. Okay, they're all an instance of what? Of a girl. They are an object. So we can say instant, we can say what? An object. Now, for example, here a boy is a class. An instance of the boy is what? Muayyad, for example. Okay, this is an instance of the boy. For example, Yusuf. Okay, they are all boys. They are instance of the class boy. Okay, I hope you can understand the meaning of instance from a class. Now, this is the representation of the class. Quickly, we can say it. You put the class name, you put the attribute here, and you put the method or function here. So as we said, the class is blueprint. This is the rectangle. You split it into three areas: the name of the class, the attribute of the class, and the method. I'll give you an example later on. Okay, so the attribute describe, this is the name of the class. This is the attribute describe the state of the class, and here we have the methods of the class. This is the UML notation. This is what? The UML notation of the object and the class as well. When you draw later on the diagram, you will use this notation. This is an example for the class. The class is called movie. The attribute of the class are name, length, director, and this is the type value, and this is the method, calculate short. Okay, you see there's no values. If you put values, it will become an instance. Okay, now this is, for example, a car class name. Another example, it has the following attribute: manufacturer, color, odometer reading. It has the following methods: drive, repaint, fill with gas. Okay, now you can have another object for class like Mercedes, BMW, audio. These are instance of the class car. Draw like a class like what we did, three things, and put person here and see what kind of data can be saved. Attribute can be for the person, and what kind of method a person can. Okay, try to do that using Word or using Visual or any software program. We draw the UML diagram like this. You have to draw it UML structure, and I use that to put the class name person. I will teach you the next chapter some of the software that you can use, and we split this into two parts: methods and attributes. So for the attributes, we can say ID, for example, name, age, okay, and other things. Okay, we could so identify the type. For example, this one is an integer, name is string. You can identify that. Okay, the methods, we can say walk, talk, something that the person can do. Okay, walk, talk, run. I'm not gonna say eat because that make me feel hungry. Okay, but it's a correct one. Okay, it's a correct one. Work, study, yes. These are what maybe a method. That's perfect. Play, yeah. You can do any verb that the person can do. Now be careful. If you say have a person object in the system, the probability and the attributes and the behavior depend on the system. So you have to model the object according to the system needs. If I have a student, if the person is in the college, I will not put wait. I will not use run. I will not use eat because that has nothing to do with the system. Okay, the system require study, attend the class, register a class, student ID, student major, student GPA. So you have to model the object according to the system needs. Okay. Okay. Now relationship among class. Okay. What do we know about the class? We know that the class is a collection of objects that have similar attributes and similar behavior. We also know that we can instantiate a class by getting objects. You can say that the class has attributes, state, and methods. We know that class represent an object, so they communicate through calling methods and passing message between these classes. Okay, so the relationship is all about what? Inheritance. It's all about what? Inheritance. So all the relationship basically are inheritance, but in different way. Okay. Now, the first relationship that you need to know is association, which is basically all the relationship we call them are association. Okay. Now, each object in the system what is associated with another object. Each object is associated with one object or more than one object. Okay. Association means what? A relationship between the objects. Okay. You can refine the relationship. You start building the new relationship when you start the system, but after a while you can refine the relationship, change it, and make it more much better. Now, the association could be one way, okay, and but it's not a good association. Always association what is bidirection, okay. It could be in both way. This object is associated with this object, and this object is associated with the other object. So the association is always what? Bi-directional. That means what? In both direction. In both direction. This is why we don't put a rows, because that means that both of them are associated with each other. As an example, okay, we have a school, a college or a school, and we have a student. Okay, we say that the student study in a school. Okay, the student study in a school, and we say a school enrolls student. Okay, so there's association between school and student. Okay, students study in school, or you can say enroll the school enrolls student in the system. So there's association between school and student. Similar way between class and student. Similar way between company and employee. Similar way between bank and customer. Okay, there is always association. Always there is association between objects. This is an example of association. Remember, association is bidirectional in both ways. That means. Okay. Now, when you do that, we always use association in all the application. In object-oriented programming, we use it on database, we use it on programs, we use it everywhere. Okay, we have something called object-oriented database as well. We have object-oriented programming. So we use association in all these things to model the objects or the program or the database or anywhere in the IT. Now, if you want to understand the system more perfectly, okay, and look at the object and how their relationship between each other, okay, the association gives you an indication about all these things. It tells you which object interact with the other object, which object has a relationship with other objects, and so on. Okay. Now, also, it design what? Responsibility. We say that each object has a role and responsibility. When you build an association between two objects, you specify what is the responsibility of this object and what's the responsibility of this object. Okay. All relationship between object what? Always. All relationship are what? Association. All kind of relationship association. Aggregation, composition, inheritance, all of them we call them what? Association. All right. So when I ask you what kind of relationship between two objects, don't say association, because all the relationship are considered association. Okay. The association is you draw between a line between what? Between two objects, the class A and class B. If I want to say they are associated with each other or there is association between them, I draw a line between them like this. One single line. Okay, this is association. All right. Now we have something called association degree. Association degree. Now association degree, it means how many class involved in this association. So we can have association that contain only one class. For example, we have employee class. Okay, the manager are employee in the company. So what we say, we build a relationship from this class to the same class, and we say employee, there's a manager in between the employee, who manage what? Who manage the employee. So we call this what? Honorary relationship. Why we call it honorary relationship? Because there's one class in the relationship. One class on the relationship. Okay? We have manager and we have employee. Now, if you say binary relationship, you split them. You say we have manager, we have employee. How many classes in the relationship? We have two classes. We have two classes in the relationship. If we have two classes in the relationship, we say what? Binary. Binary relationships. Okay? If there's more than one class, okay, three or more, okay, we call this what? Ternary relationship. So we have three classes here: manager, supplier, and employee, and they're all in the same relationship. So we call this what? Ternary relationship. So the degree of the association means what? How many classes in the association? If it's one, that means binary. If it's two classes, we say binary. If it's more than two classes, three or four or five or whatever, we call it what? Ternary as a relationship or ternary association relationship. These are the degree of the relationship. I want you to understand what's the meaning of the degree of the association. Now, other thing is that multiplicity. Okay, multiplicity means what? You already implement that. It's similar to one, one to many, or many to many. Okay, it means how many objects can participate in the association, not a class object. How many objects? Okay, so for example, we have 1 to 1. Okay, that means a single object in A is associated what? With a single object in B. So we put 1 here. Sometimes it's 1, we don't put anything because that means 1 to 1. One object from A associated with one object from B. Okay, single object only. One to many is different. One to many means what? When one object from A is associated with many objects of class B. So we have here star. Star means what? Many. Okay, one object from A is associated with many objects from B. That means a single object is associated with more than one object. One object is associated with more than one object. Okay, many to many is many objects associated with many objects. So it's represented as M to M. Okay, it's represented as M to M. An object of class A may be associated with many objects from class B and the opposite. Many to many is represented as star to star. Many object in A is associated with many object in B. I can say it in a different way. An object in A is associated with many object in B. And an object in B is associated with many objects in B. So the many to many is basically a combination of A and B, a combination of, this is A and B, a combination of one to many and also the opposite one. This is B, this is A, and this is one to many. So when you combine them, it's become many to many. One object in A is associated with many objects in B, and one object in B is associated with many objects in A. So the relationship will become many to many. Okay, remember that multiplicity means the number of objects that participate in the association in the diagram. So multiplicity indicator, exactly 1, 1. Say A is associated with B, and you put exactly 1. Okay, 0 or more, we put 0 dot star. So for example, A, one object of A is associated with 0 or more object. That means an object in A could be associated with none object in B, that means 0, no object, or 1 or 2 or 3 or 4 or 5 as many as you want. Okay. Now, if you say one or more, that's different. Okay, one or more, if you draw a relation between A and B, and you say 1 to 1 or more, that means an object from A is associated at least one object from B. At least, okay? At least one object, or 2, or 3, or 4, or 5. But minimum one object. There must be a relationship. But if you say 0, it could be no association. Okay, it could be no object associated from A to B. It could be 1, could be 2. But if you say 1 to many, that means at least one object from B must be associated with an object from A. 0 or none, that means what? Nothing. 0 or 1 is the same. Instead of 0 or more, we have 0 or 1. That means each object in A is associated with no object or one object maximum. Maximum one object. Or 0, no object. Okay? You can specify the range, for example, A to B. I'll give you an example, real example. A could be associated with 2 to 5 from B. Okay? For example, a student can register 1 to 5 courses. Minimum 1 courses, maximum 5 or 6 courses. This is N to M. We call this one N to M. This one is 0 to 1. This one is 1 to more. This one is 0 to more. This one is 1 to 1. This is how we implement multiplicity. Okay, either 1 to 1 or 1 to many or many to many. This is an example, shows the relationship. For example, here, 1 to what? The head is part of the person. Okay, aggregation is part of. Is what? Part of relationship. Part of. That means we have the outside object, and there's object inside it is part of it. Okay, part of it. Also called composition. Composition is a very strong relationship, very strong aggregation. When object contain another object, we say what? Aggregation. Okay. Now, a class associated with another one, but part of it. For example, a student studying in the school. Okay. A student study in the school. Okay. But he is not inside the school all the time. Okay. Could be outside the school. So this is normal aggregation. This is what? Normal aggregation. Because the student is part of the school, but it could be independent. It could leave the school and go home. The school is still a school. But if you say, for example, a car has an engine, okay? A car has an engine. A car contain what? Engine. If you take the engine out, we cannot consider it as a car. It will not be working. So this is called composition here. Student and school and student are what? Normal aggregation. Normal aggregation. Okay? If the relationship is not strong, they can be independent. But if the relationship is strong, we call it what? Independent. We call it composition. Composition. Okay? That means what? The inner object has no relevance without the output object. The inner object has no importance without the outer object. Okay? It could be multiple level. For example, a person has a hand. This is aggregation. And the hand has fingers. So we have two level of aggregation. We can have also hand, fingers has nails. Okay, so this is multiple level of aggregation. You can go further, more and more. This is an example. A vehicle has a driver and has an engine. The relationship are aggregation, but the aggregation between the driver and the vehicle is normal aggregation. The driver can leave the car, that's fine. The car is still a car. But if the engine took off from the car, that's not considered as a car. So this is what composition now here become. Very strong relationship. This is how we implement composition. This is how we implement aggregation. Okay? All right. Inheritance is another type of relationship, which means that a class inherit something from another class, or an object inherit other properties from other class. This is an example. This is a lion, and this is the lion son. Okay. Now the lion will inherit what? Main father. So here the father, we call it basic class or super class or parent class. Okay, they have different names. And the son, we call it derived class. Okay, derived a class that inherit the shape, the color, the eyes, the things from the main class. Okay, either properties or methods. Okay, now the inheritance, that means share what? Share attribute and method between classes. So if I say the college has, for example, employee and what? Has employee, okay, and has also student, for example, 2. We can put more, okay? Student, we can put security. Both of them can share something. So we call person, for example. What kind of thing they share? They share name, they share a mobile, they share some methods, attend, for example. So these can be shared between two objects or two classes. Okay, that's the meaning of inheritance: sharing attributes and method among number of classes using inheritance relationship. Now, the class on the top, the parent class, is the general one. So the general, you say person. Okay, which person? You say it's an employee. Okay, and if you specify as well, employee, can go further. You can say, for example, shape. Okay, shape. It's a general class. What is the specific down? You can say circle, rectangle, triangle, or rectangle, or more shapes. Okay, so this is the general class. This is the what? Subclasses down here. Subclasses. The general class is sometimes called basic class or parent class or super class. Okay, and the class subclass sometimes called derived class, child class, or subclass. Okay, we will use basic class and subclass in this course. Basic class and subclass. Okay, now the subclass here inherit everything from the basic class. Everything inside the basic class will be inherited in there. So if there's a name here, there's a mobile here, I don't have to write name and mobile here because it will be inherited from where? From the basic class. From the basic class. Okay, this is an example. The picture say that. Yeah, this is the inheritance. For example, here we have an account in the bank. This is called the basic class or the super class. There's a balance, there's a name, there's a number, and there's two at behavior: withdraw and create statement. Okay. Now the account could be two types: saving or what? Checking. You see there's here, this is subclasses, and they are, okay, they have nothing. They will inherit everything here in the attribute, and everything in the method comes here. The same thing with the other class, the method will be inherited, and the attributes will be what? Inherited. It's like mine. I can use them, okay, because I inherit this. Okay, this is called inheritance. Everything in the basic class will be used in the subclass as its own member, either attributes or methods. When we say class, we mean the objects. This is an example of the, another example of the inheritance. Mammals, dogs, cat, and human, they inherit everything from a mammal. Cat, for example, we have lion, tiger, and so on. They inherit everything from the cat. Shape, rectangle, triangle, circle, and so on. Okay. We have also types of inheritance: single inheritance, multiple inheritance, multi-level inheritance, and hierarchical inheritance, or hybrid inheritance. Now, the single inheritance, a class, basically, okay, a class inherit from single class. This is what? Single inheritance. But if the class inherit from multiple class, we call it what? Multiple inheritance. Okay, this class inherit everything here, here, and everything here, here. So it has more attributes because it inherits from both of them. Similar to the mother and father, you inherit your characteristic, color, eye, hair, the body style, and the way you speak from your father and from your mother. So we call this one multiple inheritance. A subclass derived from more than one superclass. It could be 2, it could be 3, it could be 4, something like that. Multi-level inheritance is more like a tree. So it is a subclass derived from a superclass, okay, within the term that derived. For example, this is a superclass, okay, and this is the superclass, and this one inherited everything by this class, okay, derived, and a subclass derived from a superclass, which in turn is derived from another class. Now this also, okay, could be derived from another class. Okay, so this one could have, for example, another class here, and these two inherited from other class. So it's kind of, a network drawing. Hierarchical is like a tree, Everyone inherit from the one on the top. Okay, everyone is inherit from the other one in the top. So this class here, A, inherit everything from class 1, from class 2, and from class 3. Is this everything on the line will be inherited in this class. So this is hierarchical. Hybrid is a combination of all of them. Hybrid is a combination of all the single, multiple inheritance, and hierarchical, and so on. So you could combine all of them. This one, as for example, could be like this. Inherit from this and this. So this is, we combine the multiple inheritance with the hierarchical, and something like that. Okay. So this is the type of inheritance. There's some example drawing. I already explained this, okay, and gave you an example. Have a look at these examples and see these things. Generalization and specialization. Generalization is going from the bottom to the top. I'll give you an example. I say, what's your major? Okay, you say my major is security. But I am in what? I am in the network and security department, and I am in the IT school. So you go from the bottom to what? To the top. You go from the subclass to the superclass. From the bottom to the top. We call this what? Generalization. Okay. Specialization is the opposite. From top to down. What's your major? IT. Okay. What's your specific major? Network and security. And what is the main major? Security. So you go from the top to the bottom. We call this what? Specialization. Okay, you need to understand the difference between specialization and generalization. This could be implemented here. So if you go from top to down, we call what? Specialization. You go from bottom to up, we call generalization. So airplane is a vehicle. Okay, this is generalization. But a kind of vehicle is a ship. We call specification or specialization. Okay, we go into more deeper details, not a general view. Now, in this class, we also study the meaning of the objects and the object boundary. We study some of the object must-has like state, identity, behavior, and characteristic. And we study also each object has a role, and the role is just a mask for the objects. It define how they communicate with other objects. Responsibility also, it define what is the purpose of the object inside the system. Object interact with each other through calling methods or through interaction, sending a message. We talk about the relationship composition and aggregation. We say that it's aggregation and composition is part of relationship, and composition is a strong aggregation. Okay, we say that an operation denotes a service that a class offer, and also we talk about that a class represents a collection of objects that have similar attribute and similar behavior. And remember that association is what is a bidirectional. We talk about inheritance, okay, and we say all the inheritance are or the relationship are inheritance, and we talk some sample of the relationship such as association, and we talk about the degree of the association, the multiplicity in the association, and also we talk about the inheritance and the type of inheritance and some kind of inheritance, single inheritance, multiple inheritance, and until the hybrid inheritance. And we talk about the difference between generalization and specialization, specification, we call it another name. So this is exactly what we mentioned in this class. Okay, this is an activity for you. Okay, this is a good activity for you. The activities say that you have a university, okay, and the university contains faculty, okay, such as engineering, such as IT, business. Each faculty divided into department. For example, the IT department divided into what? Into math and IT, for example. And each department has a major. So in IT, for example, we have security, we have software development, we have network, and so on. And the student study courses. Okay, there's a lecturer can teach many courses, and the courses can be taught by many lecturers. Okay, and the student can enroll in any major, where major can contain many students as well. This is a description of the relationship between what? Inside the organization. What I want you to do is to identify the main object in the system. Okay, what are the main objects in this system? What are the relationship between these classes or objects, that classes that represent the objects? So I can say that we, for example, we have lecture, we have student. What's the relationship between them? Okay, identify the main attribute for each object and the main behavior for each object. Okay, try to use online tool to draw the relationship between them. Okay, just try. Okay, I'll create a link on the model so you can submit your answer on that link. You can use, I'll show you what to use. You can use one of the online tools. For example, I'll show you one of the tools. It's a free, www.iodro, okay, draw.com. We will use this sometimes in the second chapter to draw some of the diagrams. Okay, now the Idro is more like free online tools that you can use to draw the website. You're going to use it to draw the relationship. It's a free online tools. You can click on start, okay, and draw a relationship, a simple relationship. I'm going to show you how to draw the class and how to draw the relationship. So basically, create a new diagram. Okay, and you can save the diagram. If you have a diagram, you can save it. So what kind of diagram we're gonna use? You're gonna have to use UML diagrams, okay? UML diagrams, and we will use a class diagram. Okay, remember that, class diagram, okay? Class diagram, okay? So this is the class diagram. I say, okay, create. Okay, and this is the class diagram, so you can use it and to draw a lot of things. Okay, it's already there. You can delete, get a practice on that. You can delete, you don't want this one, you can delete it, or you can update it, change it. For example, I could use this one as student, like this. I could give it a name, phone number, email address. I could add something to it. Okay, you can add something here, text, and add more in here. Okay, see that it comes like this, and you can add, for example, major. You can add GPA or anything you want. Okay, here is the methods. For example, the method, you can say register. Okay, add another method here. Call it, for example, withdraw. Any other methods. Okay, just add this because I know this is a method, so I know it is a method. Okay, add this to the end, and you can do the same for the others. Okay, you can do the same for the others. Okay, and yeah, it's like Word. You can color, you can control, and you can. The relationship is here. You can see there's more relationship here. You can use the UML one. Click on the UML. Okay, this is the UML. If you want a new class, you can also draw a new class if you want. Okay, stay here. Update this one. If you want a new one, you can say copy and paste it here and update it to another name and modify the relationship between them. It's a text. Okay, you can say here student study or enroll study, and this one I make it courses, and the relationship is, for example, many to many. You can click here and change it. Okay, you can click on the text here, text, you can change it to star, and it'll become star. Okay, I want you to get used to this one because in the next chapter, now the assignment, you're supposed to draw it using this program, or you can use Word. I want a class diagram like this, and shows the object, class here, name, attributes here, and the method here, and shows the relationship between them. Okay, try to draw it. I know you will not draw it perfectly from the first time. I know you'll have mistakes anyway, unless you have some experience in that. Okay, but make mistakes and learn. Without mistakes, you will not learn, because in the next chapter, we're gonna need this program to use it a lot. Okay, so explore the program and see what can you use and how you can create another diagram or to use it and so on. You can add from here a lot of things here. There's more down here if you want. You can go to the advanced. Okay, see more shapes if you want. Okay, but stick with what? With the class diagram simple. The class name here attribute here, and the behavior, and you draw the relationship between them. Okay, the relationship lines are already here. You can choose them and draw them here. You can change them as well. You can have scratch board and draw whatever you want. Drag an element here and you can do whatever you want in it. Okay, like this, and then you can have scratch and change it and add it. Also, you can use this one for the relationship lines or association or anything. You can add rectangle, you can add text, you can link. It's from here. You can use here. Or you can use a freehand drawing. You can start drawing by yourself. Okay, start drawing by yourself like this. You can do it by writing like this. I can, write class, blah, blah. But I prefer to use, it's more understanding. Okay, so you can use both. Anyone, get used to the program and see how can you use it and try to solve the activity using this program, IO Draw. Okay, I hope you get used to that one.